So once we've done all of the experiments, we've got our head around titrations, a really big part of understanding it is being able to calculate the concentration of the unknown. So I've got some example practice questions that I'm going to go through now, and I'm going to teach you the way I would teach my students. So some things to look out for, things that I want my students to be careful of. I'm going to show you the steps that I talk through with my students as we're completing titration questions. I do want to point out at this point that sometimes I've seen people complete titration questions using the formula M1V1 equals M2V2, and I would highly recommend not using that. The reason being is that that formula is meant for dilutions, and it is not meant for stoichiometric calculations in titration. Yes, if there's a 1-to-1 ratio, often we end up with the same answer. However, it's not the correct practice to use, and it also doesn't get students into the habit of looking out for things like molar ratio. So I'm going to show you how to complete these titration questions stoichiometrically, and this is the way that I would suggest you teach your students as well. So regardless of whether it's a titration or not, the number one rule is always to write the fully balanced chemical equation. So in this question, I've got a neutralization reaction. I have got hydrochloric acid and sodium hydroxide. So I'm going to write out the chemical equation for that. In this particular example, that equation is already balanced. Now I want to calculate the moles of the known. So in a titration, we always have a known and an unknown. And so in this case, we have been given both the volume and the concentration of the sodium hydroxide. And so we can use our formula, which is that the number of moles is going to be concentration times volume to work out the number of moles of sodium hydroxide I have. I always encourage my students to always convert any value, any volume that is in mils to liters, because that is what we use in chemistry, and just to make sure that we don't end up with any problems later on. So now I've got the number of moles of our sodium hydroxide, and our molar ratio of our hydrochloric acid to our sodium hydroxide is actually 1-to-1. Okay. And so now I know the number of moles of hydrochloric acid I have, and I've also got the volume. I can now use the same formula, but just rearranged to work out what the concentration is. So I'm just going to go through another example now. So here we've got a very similar example. We've got 25 mils of a 0.5 molar hydrochloric acid to neutralize 0.345 liters of a sodium hydroxide solution. So we're going to use the exact same process here to calculate the concentration of the sodium hydroxide. So again, we're going to write the fully balanced chemical equation. We're going to calculate the moles of the known. In this case, our known is the hydrochloric acid. So in the last example, our known was the sodium hydroxide. This time we actually have more information about our hydrochloric acid. Our ratio, like the last one, is a 1-to-1. So this is how many moles of our unknown that we have. And again, we can use this formula here. So our concentration equals moles over volume. Our volume's already given to us in liters here. Now this last one's a little bit different because our molar ratio is not a 1-to-1. So Again, I'm still going to use the exact same steps that I've used for each of these. So firstly, writing the fully balanced chemical equation. Because it's a neutralization reaction, we know we're going to end up with a salt, but also water. So our salt is going to be potassium sulfate. And our equation is now balanced. Next step, calculate the moles of the known. Our known, the one we have the most information about, is our potassium hydroxide. Now our ratio of our KOH to our H2SO4 is 2 to 1. So what I actually need to do is I need to divide this by 2 to work out the number of moles of our H2SO4. Now I can use this number here, the number of moles of our H2SO4, to work out the concentration. And that gives us our concentration of 0.1 molar.